The next presenter, for those of us who would have been in the University of the West Indies during the period 1977 to 2005, he would be excuse me. Yeah, he is certainly no stranger to us. Engineer Dr. Robin Osborne was born in Dominica. He worked at Kariri from 1972 to 1979 at the Faculty of Engineering. The University of the West Indies from 1977 to 2005. I think I'm doing something here. 2000. Sorry, let me start again. From 2008 to 2011, he was an associate professor and vice dean at the Faculty of the Built Environment, UTEC, Jamaica, and he now resides in Florida of the United States. Experienced in both undergraduate and postgraduate university teaching and research, he has been involved in the supervision of 2 successful PhDs at UWE in St. Augustine, one in civil engineering and the other in chemistry. The latter was awarded with high commendation. His major specialization is concrete technology and construction, but he has also worked throughout the Commonwealth Caribbean as a consultant to Caribbean governments and companies on aggregates, standardization, and post-disaster recovery. He has also worked as an instructor in concrete technology and the maintenance of buildings. From 2012 to 2013, he was one of 2 consultants on a year-long CDB assignment, Institutional Strengthening of the Technical Services Division of the Ministry of Public Works, Energy and Ports, and the Government of Dominica. He's a fellow of the Association of Professional Engineers of Trinidad and Tobago and is a well-known presenter at Caribbean engineering conferences in Jamaica and Trinidad and Tobago. Ladies and gentlemen, fellow engineers, I introduce Dr. Robin Osborne.
Good afternoon, fellow engineers and all necessary dignitaries. Robin Osborne. I'm going to speak a little bit on the subject here, and I'll be as quick as possible getting through the preliminaries because I want to get to my main point of interest. The subject is concrete roads in disaster management, and I want you to half memorize that picture. It is a no-slump concrete being laid. If you look carefully, you will see dowels already placed for joint control, which will be shown later. And some of these pieces of equipment can spread both asphalt and concrete. I'm going to find that the comparison is inescapable. Let me make sure I have this. Sorry. Which is my, that's, okay, good. Okay, good, thank you. Oh, I can use this one too, that works, good. Sorry, never used this one before. I would like to acknowledge the support of the marketing department of TCL, Cecil Chin, engineer, for some of his very useful contributions and counsel. Larissa Smith of Carib Cement, General Manager's Office, Arawak Cement. We cannot escape discussion and comparison between the 2 main forms of pavement systems. And when I look at the literature available, I've looked at American literature and some British literature, the battles that continue to go on are fierce. Engineers are often involved on both sides. There is hype and distortion. And one of the things that is unfortunate is that depending on who pays your salary, you sing a tune to suit. I'm going to try to walk a higher road than that. The issue is complex, and there is need, I'm sorry, let me go back. There is need for objectivity and relevance to the Caribbean in any comparisons which we do. It's a very narrow subject. The literature I looked at was not very helpful because it tended to compare asphalt and concrete systems under normal traffic. We are in a disaster context, and so I've tried to keep my focus on that. So in broad structure, I'll be doing some comparisons between the two systems. So, and my key thing is to look at some projects in the Caribbean, and then a few comments on pitfalls to be avoided, etc. My thrust is prevention. That is, if a similar impact can hit two critical systems, and one of them is likely to be operable and usable and serviceable after, then that obviously is a critical consideration in disaster planning and management. Of course, there are issues of cost and so on. So that key thing, what kind of effect can it sustain and remain operable? How does it contribute to post-event recovery? Let me be very honest and say that any system can be competently or incompetently designed, regardless of whether it is made out of concrete or made out of asphalt. And we need to take note of recent developments in this area in concrete, because they give us considerable flexibility in terms of what we can achieve. In addition to pavements, I quickly want to add these things. I will not spend time, ladies and gentlemen, fellow engineers and friends. These are all well known in our business. And concrete road systems is what I'd like us to think about. We also include all of these appurtenances, some of which can be slip-formed as the road is being made, okay? We want to look at some of these issues here. I beg your pardon. Capital cost has often been the reason why people choose asphalt. Let's face it, governments pick because it's cheaper. Because of prices rising in oil and the rapid increases in the prices of petroleum, bitumen or binder, Trinidad is unique in having Trinidad Lake asphalt as well, so that's a special scene. According to American and also to British data, and these things are detailed in my paper, I'm happy to report that my paper is already submitted. A couple copies of the pre-edited version are available at the TCL desk, and the TCL resource group is going to distribute to the tables a couple of things just for you to look at. And I will ask Michaela and Ryan to do that distribution for us now. They maybe have done it already. Thank you. We'll touch to those in a little bit of a while. So the fact is that I don't know information for Trinidad, but in the US, concrete is now enjoying bid advantages over asphalt. And some of the information quoted is like 79,000 US savings per mile, or single lane, single double, and 2x2, 180-something thousand per mile advantage in favor of concrete. So the table has changed. The playing field is no longer as traditional, and so actually in terms of capital cost, concrete is now coming in cheaper. The issue of longevity needs no discussion. We know that a well-made concrete road, and concrete roads can be badly made as well and give the system a bad name. Concrete roads generally way outlast asphalt roads because of advances in paving technology, riding quality, noise generation are equivalent at least. In terms of vehicle fuel economy, concrete roads seem to have the edge, especially in heavy vehicles, where savings of up to 20% have been recorded by reasonably independent and unbiased testing. In fact, where I live in the US, they've just upgraded part of the I-95, and it's like riding on a billiard table. And I've looked at stuff, I have not quoted it because I haven't been able to check it myself. People say that when you have with most of the modern vehicles have data capture, and simply by driving from the asphalt section to the concrete section, people are picking up like a Hyundai Hyundai Genesis going from 34 to 37, 32 to 35 miles per gallon. So that even with passenger cars which had not been anticipated, there are significant and measurable fuel economies. With the heavy vehicles, and I go to this in detail in the paper, the asphalt surface under a tire pressured to 6 bar and with a footprint of several tons is deformed. Concrete deformation is negligible. So what you have is a viscoelastic deformation that the tire is pushing before it all the time. That transfers into heat, increased engine power requirement to propel the vehicle, etc., etc., etc. So that it seems to me from what I've looked at that there are clear advantages in terms of vehicle fuel economy, emissions and all that in that area. Okay, friction skidding resistance is debatable. A lot depends on how you have finished the road, and so I'll leave that as an open. Obviously, concrete has the advantage here, advantage here, advantage here, and some advantage alleged in terms of its capacity to bridge weakened sections of the support system. This is a very strong point which I want to come back to, so I want to speed through the rest of them. This is also an advantage for concrete roads, because if you know the old Point-a-Pier Hill on the Southern Main Road, this is an area where shoving has taken place with significant deterioration of surface, the riding quality. This is an area of debate. I'm going very rapidly because we do not have time to go into detail. And again, these are addressed in some detail in the paper. This is, I just want to very quickly skip this through because we don't have time to go into it. I have indicated this only to give an example of how complex it is to do a fair comparison between two systems. I want to go very quickly to some projects because the proof of the pudding is in the eating. And the American and British literature does not discuss the comparisons under disaster conditions. So let's look at a couple Caribbean projects where history is being written as we speak, and the books are being written right now by the behavior of these projects in the Caribbean. So let's go to them. We'll go, I just want to show you some key ones, okay? This is very instructive to us. I'd like to spend a wee bit of time on, firstly, on this one, which is the Fern Gully, built 2011. Raymond Charles, engineer Charles, reviewed the design in 2008. Previous to that, there were at least 3 destructions and reconstructions in the previous 19-year period. 4,000 vehicles per day approx. Truck passage is prohibited. We see buried services at risk. And what has happened repeatedly, this is to the south proceeding towards Ocho Rios. The road failed several times and had to be repaired with all the attendant capital and socioeconomic costs. Since the concrete replacement, there have been some severe testings from erosion and storms, but there's been no problem. The road is still breathing easy, okay? I could go on, but I'm truncating. I want to cooperate with everything, including lunch, so you can ask me questions after. This is the Bogwalk Gorge adjacent to Rio Cobre. You can get from the size of the man an idea of a major main National Water Commission of Jamaica feeding Kingston. Because the Cobre often overflows, parts of this road are often closed, but more so, the road becomes damaged. It was repaired in concrete. I think the figure is 2008. It's in the previous slide. And since then, there has been no trouble at all. To make it interesting, the National Water Commission got a contract for replacing parts of this. So after the concrete was placed, they had to cut back into it to change this. This is a very familiar story. It was apparently properly done, and since the replacement and repair of the concrete pavement, again, no need for intervention. I think the facts speak for themselves. I want to speak about a little project near Carib Cement in Jamaica called the Rockfort Turnaround. It's a regular roundabout. It is traversed largely by heavily laden cement trucks. There was a collaboration between the National Works Agency and Carib Cement, and they started seeing premature surface degeneration, that is, coarse aggregate being exposed. I was asked to look at it by the general manager, Tony Haynes of Tobago, and I checked all the paperwork, and all the paperwork was perfect, all the specs. So I had to go on my knees, almost with a magnifying glass and a high-powered flashlight to look, and then I realized what had been done. In the same way a bad man can make a potentially good wife into a bad wife by mistreatment, I suppose the reverse is true, but I don't know. Concrete is critically dependent on what you do with the fresh concrete. I've taught this for years across the Caribbean, from Guyana to Belize. And what happened? They overworked the concrete. They caused segregation, fine stuff of high water to cement ratio coming to the top, low wear resistance, low compressive strength. In spite of this compromise of the potential quality of the pavement, and in spite of its extremely severe regular testing under heavily laden trucks at tight radii, the structure remains with no need of intervention, in spite of the fact that it was not properly done. Few other quick examples. This is Pioneer Drive C-Lots on very poor support, a demonstration strip put down by TCL many years ago and still in good shape. This is Paramin Maraval, 1995, which says this is not exactly a youngster. Close looking at the surface tells that the concrete quality was not very high. There was not enough cement in places, but still the roads have held up. For yourself, you can see. Paramin again, we go through quickly. Filling station in NP. This is new, so it's too soon to make judgments, but concrete was chosen because of the very high wheel loads that were anticipated there. Another Mayo Quarry, again severely tested, part of the company's own infrastructure, which has stood up well. Another picture of Mayo. I want to talk quickly of one or two other things. The recent, and I only have about 3.5 minutes according to me, the recent December 24th deluge in the islands, I've spoken with one of the engineers to the department to which I was a consultant up until recently, and he says something which I am quoting largely by memory from my paper. He said, Robin, we did the homework and we've seen the results. 125 to 150 millimeter concrete pavement, especially in hilly areas subjected to intense rain, which is a critical challenge. It blows my mind, and I haven't seen the actual information, but CTO Kendall Johnson, former UWI grad, assures me that there are parts of Dominica, where I was born, where the rainfall is over 10 meters per annum. Now, try to grapple with that in your mind. He said there's evidence, clear evidence of 7 meters on the rain gauges. And in the Mont Wapiton area, which is a UN heritage site, there are 3 peaks over 4,000 feet high, and the extremely intense weather events there mean that even when a lot of other places are dry, and even in the dry season, rain is coming down bucket or drop. There's one area where within 1 mile there are 16 natural drainage crossings. So that's an idea of how it is in some of the islands. And he said further that the 24th of December last year event has proven the considerable superiority of concrete in resisting erosion, etc., in these particularly challenging areas of steep slopes where plenty of water is running quickly, high erosive capacity. I've gone into much more detail in the paper itself. He also adds that when they send clearing equipment to clear debris and trees which have fallen, that sometimes damages an asphalt surface. The concrete is relatively impervious to that kind of damage. He admits that if a 10-ton boulder falls from any significant height, you cannot economically design any road system against that kind of unnatural, is it black swan is the name? Something like that. Okay. But ladies and gentlemen, I'm cutting before I hear the ring on the glass, because people are hungry and I'm the last one in the morning, and so you're tired of hearing people going over time and doing institutional defense and other things. So I have to be as clear as I can be. I think what I'm basically saying, and I summarize, that there are a number of potential advantages of concrete road pavement systems which we have not looked at. And the present developments in mixed design, accelerators, superplasticizers, and new pavers mean that we can do a whole lot of stuff much better than we have been able to do it in the past. And even then, if you look at the things you have in your hand, there's one of them is a road that's 100 years old, cracked up like an old person's face, Belknap Street in San Antonio, Texas, still going strong, and you can see some of the service life issues. So definitely in terms of service life and maintenance and resistance to erosive rain events, we don't need a hurricane. We only need a lot of rain, and we have crises, whether it's the flooding of Port of Spain, whether it's road erosion in Paramin, in St. Lucia, in St. Vincent, in Dominica. What we are saying, and I'm not saying this on behalf of the company, I've done a fairly thorough review of the literature available. There are a number of advantages that are potential, need to be explored, but this will require collaboration, investment, and initiatives between all the stakeholders, TCL, designers, contractors, government. Thank you very much.